Hello everyone, Assalamu alaikum. It's Sanjay Purna Sarkar. Ours is ACED School English version section and it's the time of physics. Okay, today I'm going to discuss about chapter 5 of physics book of class 9 and 10. So, chapter 5, that is state of matter and pressure. It's a huge chapter and there are a lot of topics. So it is not possible to discuss the whole chapter in one class. I'll try to explain the pressure and area and try to give you a clear concept about the relationship between force, area and pressure. Okay, so at first you have to know what is pressure actually. Pressure is actually the relationship between force and area. Okay, so pressure is the relationship between force and the contact area between two objects. We can say it pressure equal to force divided by area. We know that the unit of force is Newton and the unit of area is meter square. So the unit of pressure is Newton per meter square. We can also say Pascal after the name of French mathematician Blaise Pascal. Okay. Now, if you consider Newton per meter square, then if it is 1 meter square, then how much amount of force is it or Newton is it? That will be the same amount of pressure. That means if it is 1 meter square, then the force is 30 Newton, the pressure will be 30 pascals. So if I ask you, what do you mean by 20 pascal? What do you mean by 20 pascal? Okay, we can write 20 pascal equal to 20 Newton divided by 1 meter square. That means for 1 meter square area, if 20 Newton force is felt or applied, then the pressure will be 20 pascal. Okay, so the unit of pressure is pascal or Newton per meter square. There are a lot of units also. Now I will try to explain you how intensely a force is being applied, and will try to explain you with a simple example. This is a balloon, and if you grab this balloon and punch it with a pressure, maybe nothing would happen. See, nothing is happening. Okay, but if you grab this same balloon and apply pressure with the same force as before, then see what is going to happen. Yes, the balloon is popped. This is because the area of this pin is much more smaller than my punch. Okay, maybe it is 1000 or 2000 times more smaller than this. So the pressure exerted by this pin also will be 1000 or 2000 times greater than my punch. Okay. So pressure is actually how intensely the force is being applied or applied to. Okay, so we can write pressure is equal to magnitude of force divided by area is being applied to. So pressure is magnitude of force divided by area is being applied to. From this equation, you can say same amount of force can exert different levels of pressure. Okay, because if the values of area varies, then the amount of pressure will also varies. If the area is large, then the pressure will be small, but if the area is small, then the pressure will be large. So you must remember two important things. First one is, if pressure is distributed on a small concentrated area, if force is distributed on a small concentrated area, then the pressure will be large. But if force is distributed on a large area, then the pressure will be relatively small. Okay. Now I will prove this with two simple calculations. Suppose this box is on the table, and the contact area of the box, which is contacted with the table, contact area will be 2 meter square. That means the length of the box is 2 meter and the base of the box is 1 meter. 1 meter times 2 meter equal to 2 meter square. Okay, that means area of the box is 2 meter square. Suppose the weight of the box is 80 Newton. The weight of the box is 80 Newton. And you know weight is one kind of force. Weight is one kind of force. Okay, so we can say force is equal to 80 Newton. So we can calculate the amount of pressure that is exerted by the box on the table. Okay, we know pressure is equal to force divided by area. That is, force is 80 Newton and area is 2 meter square, equal to 40 Newton per meter square or 40 Pascal. Okay. So the amount of pressure that is exerted by the box on the table is 40 Pascal. Okay. Now I will show you how same amount of force that is 80 Newton can exert different levels of pressure. And I will also give you another example. Okay. Okay. Consider this pin. Okay. In its very tip, the area is very small. Okay. The area of this pin, of the tip of the pin, maybe or approximately 0.00000025 meter square. Okay, it is approximate. It must be approximate value. Okay. Then if I apply the 80 Newton force to the center of this pin, that the same force which was applied by the box on the table. Okay, the entire 80 Newton force will transfer to this pin point. Okay, transfer to this pin point. Now calculate the value of calculate the amount of pressure that is exerted by this pin on the table. Okay. Okay. Here area is 0.000025 meter square and force was 80 Newton. Okay. So pressure will be force divided by area equal to 80 Newton divided by 0.00000025 meter square. That will be 32 million Pascal. Okay. It is huge amount of pressure. Okay. So this pin is exerting a huge amount of pressure. It is 8 million times greater than the pressure was exerted by the box. Okay, it is 8 million times greater. Amazing, right? So we can easily say that same amount of force can exert different levels of pressure. But one question may arise also. Okay, why I am using 0.000025 meter square? I am using meter square as a unit. Yes, I can also use square millimeter. Okay, that will be 0.25 square millimeter. Okay, 0.25 square millimeter. So for this the pressure will be 80 Newton divided by 0.25 millimeter square. Okay, the value will be 320 Newton per millimeter square. But for this we cannot use Pascal as a unit, because it is the Newton per millimeter square, not Newton per meter square, because 1 Pascal means 1 Newton per 1 meter square. Only for meter square we can use Pascal as a unit. So I have to use Newton per millimeter square, not Pascal as a unit. So the final thing is, the same force can exert different levels of pressure. This is the relationship between force, area and pressure. Okay, that's all for today. Thank you very much, and thanks to all for watching my video, and I will try to upload another video on this chapter very soon, and till then, thanks a lot.